Hello folks, today we're going to talk about energy transformations and go through this worksheet. This is a really short one. Okay, which has more heat, Smith Mountain Lake or a cup of boiling water? Well, the boiling water certainly has a higher temperature, but if you think of the total amount of heat that is stored in the Smith Mountain Lake versus a cup of water, right, the total amount of heat is much, much bigger in Smith Mountain Lake, because Smith Mountain Lake can just absorb or give up far more heat than a cup of water. For example, let's think about if I want to raise the temperature of the lake 10 degrees and I want to raise the cup of water 10 degrees, it takes a lot less energy to raise the cup of water 10 degrees, but it takes a huge amount of energy to raise the lake 10 degrees. Okay, so the answer here is Smith Mountain Lake has far more heat, even though the temperature of the boiling water is much more. What happens to different two objects when different temperatures come into contact? Well, the heat or the energy always flows from hot to cold and never the other way around. So, for example, let's say that you touch an ice cube with your hand. All right, what happens? Well, the heat goes from your hand. I'm not even going to try and draw a person's hand. It goes from the person's hand to the ice cube. So what happens is that the heat is leaving your hand and it's going to the ice cube, and then the ice cube starts to melt. Okay, so the energy is going from the hot thing to the cold thing. Right? And you say, well, wait a minute, my hand feels cold. Well, your hand feels cold because the heat is leaving your hand. So as a result, the absence of heat in your hand makes your hand feel cold. All right, exothermic versus endothermic. Remember that exothermic means exothermic is releasing heat, if I could spell, that would be good, R-E-L-E-A-S-I-N-G, releasing heat to the environment, or to the surroundings, if you will. All right. Well, condensing steam, let's think about evaporating alcohol first, and let's go back. If I'm evaporating alcohol, that means the alcohol has to be absorbing heat. Because for it to evaporate, it has to gain heat to be able to leave the alcohol. Okay? So those particular molecules that are going to evaporate have to gain heat. So as a result, this is endothermic. E-N-D-O, endothermic. Let's look at condensing steam. It's doing the reverse. It's going from a gas back to a liquid. So it is giving up energy. So when you think of steam, or let's just say that you're something similar, is you're sitting at Famous Anthony's with a glass of cold water, and there's ice cubes in it. All right, so it's very cold, and the water that's in the air hits the outside of the glass. And when it does that, it condenses. Why? Because it gave up its energy to the glass. The energy went from hot to cold, and the energy that was in the gas molecule went to warm up the water just a little bit. And so that water molecule condensed on the side of the glass. So that would be, it gave up energy. It gave up energy, so it is exothermic. I had to think about that one. Right. Because when we think about something, we think about burning. This is the excellent example. Burning alcohol or burning water, burning anything is always exothermic. It's always heating up the environment. It's always giving up energy to something else. All right? It's always releasing energy. Well, that's what the steam was doing when it condensed. That's what the alcohol does when it burns. What does a potato do? It takes energy out of the oven and takes it into the potato to cook the potato. So this absorbs energy. So as a result, it is endothermic. Energy always flows from the hot thing to the cold thing. Always, always, always. Hot, going to cold. And so when you open the door in the winter and your mom says, quit letting the cold air in the house, you're not really letting the cold air in the house, you're letting the heat out of the house. So be polite about it, of course. But you can tell her that what we're really doing is we're heating the outside. We're heating the outside. So we are not letting the cold in. The lack of heat, the heat moving out the door, makes us feel cold. All right, folks, that's it. Told you it was short. Have a great day. We'll see you in class.